section 5.6, part 2, we're going to talk about dividing complex numbers and conjugates. So two complex numbers of the form a plus bi and a minus bi are called complex conjugates. Remember, they are conjugates because the sign of the second term was changed. It was plus bi and then it became minus bi. Remember that the product of complex conjugates is always a real number, thus there is no I when you multiply them together. So remember that complex conjugates work as a team, and of course there is no I in team, so there should be no I in your answer when you multiply the conjugates together. If we look at this next examples, it says find the complex conjugate of each complex number below, then find the product of the complex conjugates. So we have 2 plus 8i. The conjugate of that would be negative 2 minus 8i. Notice I only changed the sign of the second term. This is not like the additive inverse. The additive inverse of this would be positive 2 minus 8i, but that's not what we're finding. And if you want to find the product of something, you multiply to get the product. So your first numbers multiply first, so that would be 4. Then the outside numbers, that would give me plus 16i. Inside numbers, so minus 16i. And the last numbers, minus 64i squared. Notice that we have 16i and negative 16i are like terms, so those cancel out. We have 4 minus 64i squared. Remember, I squared is really negative 1. We learned that in the last lesson. So 64 negative times negative 1 becomes positive 64, and 64 plus 4 is 68. Notice that these were conjugates. When we multiplied them together, it got rid of that I. Just like when we multiplied with the radicals, remember I is really a radical, so it got rid of that I or radical term. For b, same thing. So the conjugate of 7 minus 2i would be 7 plus 2i. We want to then find the product. So 7 times 7 is 49. Then we got plus 14i minus 14i, and then this would be minus 4i squared. The 14i and the negative 14i cancel out. Those are like terms. So 49 minus 4i squared is really negative 1. So 49 plus 4 equals 53. And for the last one, we just have 6i. Now, when this happens, what I suggest doing is just writing it as the complex number form, 0 plus 6i. So then the conjugate of 0 plus 6i would be 0 minus 6i, so the negative. And we don't really need those zeros, so really you're doing 6i times negative 6i, and that's negative 36i squared, which is negative 36 times negative 1, which is 36 for your solution. Now, why do we use these conjugates? Remember, they help us to simplify when we are dividing expressions. So if you look at all these expressions that we have right here, notice each of them has an I in the denominator, and remember, I is really the square root of negative 1. Therefore, we don't like radicals in our denominator. We have to get rid of them. So if you look at a for this first one, we have 5 plus I over 2i. So that means I need to get rid of that 2i in my denominator. Notice it's just one term, it's not two, so it's not like I'm multiplying by a binomial. If it helps and you want to multiply it by the conjugate, you could do 0 plus 2i, so the conjugate of that would be negative 2i, so we could do it that way. So this would be multiplying by 0 minus 2i, or just negative 2i. So when we do that, remember, you want to multiply everything through, so we have 5 plus I over 2i times really negative 2i over negative 2i. Remember, that doesn't change my equation because it's like multiplying by 1. So then, because this is a binomial, you want to multiply each of those terms by the negative 2i. So I get negative 10i minus 2i squared over these two terms multiplied, so minus 4i squared. So that gives me negative 10i minus 2 times negative 1, because remember, negative 1 is really I squared, over negative 4 times negative 1. So that gives me negative 10i plus 2 over 4. And of course, remember, we don't like to leave our answer like this. We want to write it in complex number form, so I'd change the numerator. And I can also simplify it by factoring out the 2 from my numerator. So I'm going to do 2 times, and if I rewrite this, I have 2 plus, or excuse me, 2 minus 10i. So I'm going to factor out that 2. So I get 1 minus 5i over 4, which gives me 1 minus 5i over 2. And there's no i's in my denominator, so therefore there's no radicals in my denominator, and that would be my solution. Another way that I could have solved this problem, if I look here, because it's not a binomial in my denominator, which means there's just one term, so it's monomial, instead of multiplying it by negative 2i, I can just get rid of that I term by multiplying it by I over I. And when I do that, I would again distribute to each of these. So you get 5i plus I squared over 2i squared. And notice that gets rid of the I in my denominator because I squared is negative 1. So I have 5i plus negative 1 or minus 1 over 2 times negative 1, because that negative 1, remember, is the I squared. If I rewrite it, I have negative 1 plus 5i over negative 2, and these answers right here are really the same, because remember, we don't usually like to have the negative in the denominator, so if you change all the signs in your numerator, then you can change also the sign in your denominator, which is 1 minus 5i over 2. So that way is a lot simpler to do, and it's usually the way that I do it. However, if you want to do it the first way, that's fine. You just have to remember to simplify your equation in the end. So now let's look at this next problem that we have. So for the next problem here, and actually let me move that other problem that I just did. Okay, so I made it smaller to get out of the way. So if I look at B here, now I have a binomial in my denominator which I want to get rid of. And how do I get rid of the I in my denominator with binomial? I multiply it by the conjugate. So the conjugate of my denominator would be 4 plus I. And of course I have to also do that in my numerator so it doesn't change my equation. When I do that, notice you have binomials being multiplied by binomial in your denominator, so that means you need to FOIL that out. So 4 times 4 would give me 16, and then we have 4 times I, so plus 4i, and then minus 4i when you multiply these two, and then minus I squared. So 16, and then your I, 4i, and negative 4i cancel out. Negative I squared means you have negative 1. So 16 plus 1 gives me 17 for my denominator. Now I need to do my numerator. We need to multiply each of these terms by the 5i. So when I do that, I would get 5i times 4 is 20i. 5i times I would be plus 5i squared, and this is all over your denominator, which we said was 17. So now I need to simplify this. So I get 20i plus 5 times negative 1, because remember, I squared is really negative 1. And then if we rewrite it, we have negative 5 plus 20i over 17. And there are no common factors between the numerator and the denominator, so this would be my solution. So I would pause the video now and see if you can do C and D on your own, and then unpause it, and I'm going to work them out. So for C, again, we have a binomial in our denominator with I. We don't like radicals in our denominator, so multiply by the conjugate. So the conjugate would be 2 minus 4i over 2 minus 4i. Now I have binomials times binomial. So I have to multiply both my numerator and denominator and FOIL them out. So in my denominator, I would get 4 and then minus 8i plus 8i minus 16i squared. So the 8i and negative 8i cancel out. So 4 minus 16 times negative 1, because remember I squared is really negative 1. So in my denominator, I have 4 plus 16, which gives me 20. So that's my denominator, but now I need to box or FOIL my numerator. So the numerator, I have 3 minus 2i times 2 minus 4i. So this gives me 6 minus 12i minus 4i and plus 4 times 2 would give me 8i squared. Notice these are not conjugates that I'm multiplying in my numerator, so of course my I terms are not going to cancel out in this case. They only cancel out when you multiply the conjugates. So now if I simplify this, I have the 12i and the 4i that I can combine together, which becomes 16i. So I have 6 plus 8 times -1 minus 16i. And then that -1, remember, came from the I squared, which is really -1. So I have 6 plus 8 times -1, so 6 minus 8 gives me -2 minus 16i. So this is my numerator, but remember we're dividing the two. So -2 minus 16i over 20 is what I have. And this can be simplified because I can factor out 2 in my numerator, and I can factor out -2, but it doesn't really matter, so I'm just going to factor out the 2. So that would give me -1 minus 8i over 20. 2 over 20 is 10, so we end up with -1 minus 8i over 10 for that problem. And then for the very last one, when we multiply by the conjugate, so the conjugate of the denominator would be 1 minus 4i. So I have to, again, FOIL or box my numerator and my denominator. When I do my denominator, you should end up with, in this case, 17. And in your numerator, these are not conjugates, they're just 1 minus 4i times 1 minus 4i. So if you multiply that out, you should get -15 minus 8i. So that would be your answer. If you did not get one of those two, then just recheck your computations and make sure that you didn't make a mathematical error when you were multiplying them out.